Hello, IB. We're going to go ahead and continue with 4C2, which now that we know a little bit more about logarithm equations versus exponential equations and how they are related, we're going to go ahead and take a look at how that will help us solve equations when they're written in various forms. So in class, we discussed just how to write down a log equation. So one little mnemonic device, I guess, that will help you is BAP, your base, your argument, and your power. So one way that we can change from exponential form to log form to help us solve a log equation. So right here, our directions say write as a log equation. So right now it's in exponential form, and I want to write this in log form. So I can take my base, which is A, and then my argument, which is going to be my answer, which is Y, and then my power, which is 2. So whatever you decide helps you rewrite an equation from exponential to log form. Go ahead and make sure that that matches up for you. So now I've got my log equation, which is equivalent to the exponential equation. Another form that will help us, and it won't help with this one, it'll be a little longer for this type of question, but it will help us with others, is to take the log of both sides. So remember, if you do one operation to one side of an equation, you can do it to both sides to keep the equation balanced. So what I mean by that is if I take the log of the left-hand side, which would make the argument y, and I take the log of the right-hand side, which would make your argument a squared, I now have a log equation because I have matching bases. Remember, we're assuming base 10 if I take the log of both sides. So I have matching bases, so I can say that y is equal to a squared. So I've just added the log to both sides. So I've taken the log of y and taken the log of a squared. With my various log rules that we discussed last class, I can also rewrite log of y equal to log of a to the second power would be 2 log of a. So another way to write, if you look at this left-hand equation, I basically have it reduced down to 2. So let's go ahead and reduce this right-hand side to 2, which would mean I have to divide by log a. So log of y divided by log of a is equal to 2 as well. So just a couple ways for us to rewrite a log equation because these will help us down the road. So looking at our second example, it won't really help us just to rewrite in log form because I have 2 different bases. So it might be a little challenging for us to figure out what that form would be if I just went ahead with this first option. So instead, I'm going to go with the second option where I just take the log of both sides. So if I take the log of y and I take the log of a squared b cubed, thinking back to my log rules, I know that my product, so log of a squared, is going to be a sum of log of b cubed. Now using my power rule, I'll go ahead and write log of a squared as 2 log a plus 3 log b. So now I've completely dissected this original exponential form of an equation, and I've written it using logs. So we'll do this one more time with example 3. Remember, we're not solving for anything right now. We have several unknown values. We're just rewriting the equation with logs. So let's go ahead and do the same thing with our third one. It's going to help us again to take the log of both sides. However, when we take the log of 20 divided by the square root of n, we'll have to apply our subtraction rule for logs. So I'm going to have log of p is equal to log of 20 minus log of square root of n. Now I know I can rewrite my log of square root of n as log of n to the 1/2 power. So if I do that, I can go ahead and use my power rule, and I can bring the 1/2 to the front and make that the coefficient. So minus 1/2 log of n. Now think for a moment just how all these rules will kind of play together, because somebody else looking at this question may start it by rewriting the 20 divided by square root of n as 20 times n to the negative 1/2. So if they did that and they started to take the log of both sides, I'd wind up having log of 20 n to the negative 1/2. So now I can apply my addition rule. So I have log p equals log of 20 plus log of n to the negative 1/2, which again, now I can take my exponent rule or my power rule, and I can say that negative 1/2 is going to be my coefficient. And now suddenly I'm down to the exact same place that I was when I used my subtraction rule. Okay, so we might have a couple different students in the class who approach these questions differently, but if you're applying the rules correctly, should still end up in the exact same place. So this would be a good point to just pause for a moment and see if you could apply the same idea in reverse. So if you're given an equation with logs and I want to rewrite it without logs, which rule would we need to follow and how would we wind up going through the process? So I would pause here and try these on your own. Once you begin, we notice that we have subtraction rule for logs. So I'm going to take log of m is equal to, we have subtraction rule and we have, a coefficient rule as well here, a power rule. So remember that with this 3 as a coefficient, that really means log to the n cubed minus log p to the second power. Now I can tackle the subtraction and rewrite it as log n to the third divided by p to the second. Okay? And then I have log of m on the left-hand side. Now that my logs are matching, because remember when we don't see a base for our logs, we assume base 10, so logs match. So that means I can really just say that m will then be the same as n cubed divided by p squared. And again, in a question like this, we're not being asked to solve. We're just being asked to go through the motions so that I have some skills that I can apply when maybe I will be asked to solve for one of these for numerals, right? Which means I'm going to need some other values in here. But we're just going through the motions to see what tools I can use to get a little bit further and to rewrite my equation, see what will help us along the way. And then for number 5, I'm going to also show this 2 ways. So I'll start with one direction here. If I've got log of g, and then I have negative log of h divided by 2, that's also another way of saying negative 1/2 log h, which means I'm really looking at log of g is equal to log of h raised to the negative 1/2 power. So again, I want to get to the point where I can see that my logs are the same so that I can actually just compare my arguments. Okay, so if my logs match, I can really just say that g is going to be equal to h to the negative 1/2, or g is equal to 1 over the square root of h. Now somebody else might come along and they might say, all right, well I would like to multiply by 2 first. So I might say that 2 log g equals negative log h. If that's the case, then I can use my power rule and I can say log of g squared is equal to log of h to the negative first power. So now my logs match. So again, I'm just comparing my arguments. All right. And if that's the case, then I can say therefore g squared is equal to h to the negative first power, or g squared is equal to 1 over h. So now just think for a moment, are those actually both the same? So if I were going to square both sides, would those wind up matching? Absolutely. Okay? So I've just done the exact same question, but 2 different ways because of maybe how I see it or what I think might be easiest to help me along the way here. So you want to have all these options in your back pocket so you can pull them out whenever you need them. So last but not least, how does this now tie in with all of our previous skills? At this point, again, I would try this on your own, and then go ahead and push play and see if you match how I've worked this out. First of all, I've noticed that we're adding 2 logs. So I'm going to use my addition rule. I'm going to say log of x multiplied by x plus 1 is really going to be my argument, and then that's equal to log of 30. So if I simplify that, I'm looking at log of x squared plus x is equal to log of 30. Once I have my matching logs, right, I can really just say, well, my logs will be equivalent if the arguments are equivalent. So x squared plus x equals 30 is really what I'm trying to evaluate here. This looks like our quadratic that we've been working on for the last couple chapters. So we have a quadratic equation. I can go ahead and subtract the 30, set it equal to 0. This factors really nicely. So I'm going to factor this down into 6 and 5, and subtract the 5 and add the 6 to make a positive 1 in the middle. So my answer should be for x, positive 5 or negative 6. And I'm going to underline here, make sure you check your answers. Because if we go back and we substitute in, let's say we check our answers and I substitute in 5 for log, or sorry, 5 for x, we get log 5. Or if I substitute in negative 6 as the argument, remember that when we first discussed what a log is, it's your inverse of an exponential. So you actually do not have any negative values for x in a log function. So when you guys are actually looking at these, I can't actually put in negative 6 into log, right? I can't take the log of negative 6. Another way of thinking of that is 10 to what power would give me negative 6 as an answer. So 10 to what power would give me negative 6? And no power is going to give you that negative value, all right? So that is not going to be allowed, so I can't actually use negative 6 because x is going to have to be greater than 0, all right? So for this question, I'm going to have to make sure I evaluate my answers and go with the best choice, which for this one, x should equal 5, all right? Go ahead and try a few of these on your own. Try a couple from this section as well in your textbook, and be ready with some questions when you come to class. Have a good night.